Welcome back to Cyberpunk room build. In this episode I will make a wall-mounted lamp, explore combining different materials in a single project, add mechanical keys to the lamp, and an OLED screen programmed with a bunch of glitchy animations. Hope you enjoy it. Inspiration came from a video by Julius Makes where he showed how to repurpose a really cheap IKEA item for making a cool project case. Since I'm apparently going all in on the 45 degree angles in this room build, I had to give it a try myself. And as Julius puts it,
sure, put LEDs in it and make it a lamp, I won't judge.
So since he's not judging, let's give it a try. I fetched a couple of the candle cases for Sören from IKEA and started with the prep work. First, all the edges needed to be trimmed to make them easier to fit with the 3D printed construction. Basic wire clippers were more than enough to do the job. After trimming, I spray painted the metal dark gray since orange and white don't quite fit with the aesthetics I'm going for. Next, I designed and 3D printed the construction that will hold everything together. First finished prototype had a lot of issues, as you will see soon. But I love working in iterations like that because I can fix issues and design a solution much better when I'm holding the first prototype in my hands. This unfortunately means a lot of failed prototypes, but the end result got significantly better. I'm using the M5 type screws. And if you get the tolerances just right on your 3D prints, the screw can be screwed directly into the PETG or PLA plastic, almost like a self-tapping screw. And by using these long 30mm screws, the construction is more than stable enough. Next challenge was how to get enough light diffusion in this lamp without buying any special diffusion sheets or additional materials. I first started with thin polycarbonate sheets as the windows behind the metal, since I had them laying around from the past project. They themselves don't offer much diffusion for the lights, but make the whole lamp look much better and the space inside the lamp behind the metal sheets look much deeper and more complex. You'll see it in the later shots after it's built. My main requirement for the light source was that it's directly powered by the microcontroller to avoid any complexity in the circuit. I found this USB powered 3mm COB strip LED, which fits the build just perfectly. Now, to really address the diffusion of the light without buying any new materials, I turned to 3D printing again and quickly found a solution. Using transparent PETG with larger 0.6mm nozzle and the higher layer settings of 0.4mm, I created a really cool effect with the light. Not to mention the speed of printing, which is really awesome. I put the flat side on the front of the light diffuser, half pipe for easier printing without supports. Let's see how it looks like. In this shot you can kind of see the individual LEDs that are diffused through this large diameter extrusion of PETG. In this first prototype I was trying to connect the two pieces using the light diffuser as the connector, but this was made obsolete in the next iteration because it was just not stable enough. The light diffusion was looking really good behind the polycarbonate windows and metal sheets, but at the same time the issue with the body were becoming more apparent. The flimsy metal sheet started to bulge and didn't look really nice at all, so I had to redesign the body completely from scratch and add the proper trimming all around to hide the metal edges. But before redoing the body completely, let's finish the first prototype with all its components to see how it works. For anyone interested, the source code along with the 3D files and circuit plans is available on my GitHub page, link in the video description below. I reused the old Seed Xiao RP2040 board that I had laying around from the past project. It has the same chip as Raspberry Pi Pico, just smaller board and USB-C connection. Connected to RP2040, I used the cheapest OLED module I could get, which is 128 by 32 module with I2C communication. After soldering all of that together, I started on implementing the animations and status changes of the lamp. The screen shows if the light is powered on and at which power level it's currently on. On top of that, I added glitch animation to the text, a scan line going from top to bottom, and a white noise animation appearing randomly and changing the frame rate to appears more realistic as a white noise. After a few seconds from the last key press, the screen goes to sleep with a dedicated animation. And paired with that, of course, there's a boot up animation on the first key press during the sleep mode. The variable frame rate was necessary at some point because I was hitting a limit of the buffer in the screen module and spent a couple of days debugging those issues. In the end, it turned out to be a faulty module and I had to replace it. And that was finally the first prototype done. Now back to fixing the issues in the body. I completely redesigned the middle part to be one large piece, so I don't need so many screws and the whole double section module is more stable. Only the outer front edges are going to be transparent and the rest should be dark gray or something similar to minimize the light leaks from the back. by the way, changing filament is surprisingly easy and fast in Core 1. And here are all the gray parts printed on a single bed with only minimal supports. And here are all the parts cleaned up. Print quality is not good because I print on the fastest settings and my filament is really wet. I really need to get a filament dryer soon. For the new version, I decided to leave a strip of orange paint masked off to add an interesting detail. I didn't really love the results as my masking wasn't perfectly straight, so it looked a bit wonky. And that's the main body done. Next, the transparent outer front edges need to be put in place before the end caps can be screwed in. Somewhere around this point I decided to have two of the modules connected together to a single control cap, so that's 4 sections total. For that I made a custom connecting caps with just a hole for passing wires between. Now on to the second module. Now of course I needed to adapt the code for the second LED strip and test everything again. And while I was at it, I added an Easter egg that can be accessed with a bit longer press to both of the buttons together. It starts a breathing light animation on the LED strips and a glitchy terminal log type animation on the screen. With 2 LED modules, the wires and components were getting out of hand, and I need to clean it up too to be able to fit it in a single end cap. I redid the whole thing with a small piece of perf board and made the soldering much cleaner this time. Putting the keycaps on the switches. and adding the missing polycarbonate windows. And this is the final product. I tried 2 different LED COB strips, so the colors unfortunately don't match. I prefer the warmer one, so I'll replace the other one at some point. Now to mount it on the wall and see it in its final position, I quickly had to make some interesting wall coverings. First I use a thin burnt steel plate to be used as a magnetic board for my M5 air quality meter. Above that I decided to make it a bit more interesting by using a perforated aluminium board or aluminium sheet of the same size, but with more spacing from the wall, so I can use it with custom holders for small screen and other elements later. I was really rushing this part, so all the elements don't quite fit together, and I wasn't iterating at all or measuring precisely. I just wanted to get it over with as soon as possible to just mount the lamp and see it in place. I'll probably have to redo most of these parts later. And finally the wall-mounted lamp that follows and connects to the upper trim. Hope you enjoyed this episode as much as I did. Again, for anyone interested, the source code, circuit plan, 3D files and everything else is available on my GitHub page. Link in the description below. The animations are modular and parameterized and are reusable in any other projects easily, even with other screens. That's it for now. Thanks for watching and enjoy the ambience. Note that breathing LED animation is so slow and the brightness is so weak that it's hardly noticeable in real time. But during this time lapse it really looks distracting and annoying, I know.